So next important aspect from this chapter, that is known to be concentration modes. So before starting with different concentration modes, first of all you should be familiar with term known to be concentration. Can you tell me what do you mean by concentration? So in general it is nothing but amount of solute present in given solution, and these are the different concentration modes in front of you. First of all we will discuss molarity, then molality, normality, and then known to be mole fraction. So keep in mind symbolic notation for these terms. Molarity, capital letter is used to denote it. Molality, small letter is used to denote. Normality, capital N is used to indicate normality, and mole fraction on paper denoted by symbol X. So what about first term known to be molarity? In case of practicals also, you have to prepare different types of solution according to desired molarity or normality. So at that time, this theoretical discussion is important one. So first of all, we will start with molarity denoted by capital letter. So molarity is nothing but number of moles of solute dissolved in 1 liter of solution. So in class 11th, you come across this one. Which one? WB upon MB. What is WB and MB? WB is the weight of the solute and MB is the molecular weight of solute. So when we divide weight by molecular weight, you will get number of mole, and number of moles of solute dissolved in 1 liter solution. That gives you which concentration mode? Molarity. Suppose we want to prepare 1 molar NaOH solution. Can you tell me how much amount of NaOH should be dissolved? So sodium has atomic mass 23, hydrogen 1, oxygen 16. So NaOH has molecular weight 40. So when we dissolve 40 grams of NaOH in 1 liter solution, then that solution has molarity equal to 1. What about second concentration mode? This is known to be molality. What about molality? It is nothing but number of moles of solute dissolved in 1 kilogram of solvent. So instead of volume of solution in liter, we are going to consider here weight of solvent in grams. So here also weight by molecular weight gives you number of moles, and this number of moles of solute should be dissolved in 1 kilogram of solvent. What about third concentration mode known to be normality? Instead of number of moles as we use in first and second case, we are going to use here number of gram equivalent of solute. So when we consider normal solution, only 1 gram equivalent of solute is dissolved in 1 liter solution, then normality will be 1. So how to define normality? It is nothing but number of gram equivalent of solute dissolved in 1 liter of solution. But keep in mind here how to calculate equivalent weight of different species. In class 11, you came across different kinds of 6 species: equivalent weight of element, acid, base, salt, reducing and oxidizing agent. So in this chapter, we are going to use 3 important species: salt, acid and base. These are most frequently occur in case of MCQ also. So when we are dealing with equivalent weight of acid, can you tell me formula to calculate equivalent weight of acid? What is that? Molecular weight upon basicity. And if we have to determine equivalent weight of base, then it becomes molecular weight upon acidity. Once again question arises, what is basicity? So basicity nothing but number of replaceable H plus ions present in acid. And what is acidity? Number of OH minus group present in base, that is known to be acidity. So what is fourth one? It is known to be mole fraction. It is denoted by symbol X. What is mole fraction? It is the ratio of, which ratio? As we see here, number of moles of that component to total number of moles in the solution. That ratio gives you mole fraction. Suppose we want to determine mole fraction of component A, that is solvent. So what we are going to consider here? Here number of moles of solvent divided by total number of moles in the solution. Similarly, what happened to the mole fraction of solute? You have to divide number of moles of solute by total number of moles. Then another important concentration mode is this one, Demal concentration. So keep in mind for mostly MCQ. What is Demal concentration? molar concentration of solution at 0 degree Celsius, that molar concentration at 0 degree Celsius, it is called as demol concentration. So in addition to this, we are going to consider percentage composition of solution. So try to remember three different methods here. One is mass percentage, known to be W by W method. Another is volume percentage, known to be V by V method. And third one, mass volume percentage, known to be W by V method. So what about first method, known to be mass percentage? It is nothing but weight of solute upon total weight of solution into 100. So similarly, in case of volume percentage, what should be changed? Instead of weight, volume of solute upon total volume of solution into 100. And in case of third percentage composition, known to be mass volume percentage, what we are going to consider here? Weight of solute upon total volume of solution into 100. So try to remember these three methods: W by W, V by V, W by V. So in addition to this, if we are dealing with highly dilute solution, means what? As compared to number of moles of solute, number of moles of solvent are present in greater quantity, or solute is present in negligible quantity as compared to solvent, then that kind of solution called as highly dilute solution or very dilute solution. So there are two different concentration modes which are specially used to express concentration of which solution? Highly dilute solution. So first concentration mode in this case is parts per million, known to be ppm, and what is another one? Parts per billion, that is ppb. So how to calculate ppm concentration and ppb concentration? So check this relation. 1 ppm nothing but weight of solute upon total weight of solution into 10 raised to 6. And what about ppb? 1 ppb equal to weight of solute upon total weight of solution into 10 raised to 9. So these are the different concentration mode specially used for highly dilute solution. But again question arises, what is dilute solution? So it is nothing but solution which is having negligible amount of solute as compared to solvent. So in case of highly dilute or very dilute solution, solute present in negligible quantity. So depending upon this theoretical discussion, try to remember these important MCQ hints. What is first one? Whenever there is word dilution of solution, then we are going to use this relation. Which one? M1V1 equal to M2V2, or if normality is given to you, then it becomes N1V1 equal to N2V2. This is only for dilution. If there is what mixing of two solutions, then we can make use of these two relations, M1V1 plus M2V2 equal to M3V3. Or if normality is provided, then it becomes N1V1 equal to N plus N2V2 equal to N3V3. What about last one? How to calculate volume of water to be added directly? So volume of water to be added is nothing but N1 minus N2 upon N2 into V1. You will provide it with initial normality, final normality and initial volume. So by putting values, directly you will get how much water to be added to get desired solution. Then, in addition to previous MCQ hints, try to remember these hints also. For acidic solution, what happen? This is condition where A indicate acid, B indicate base, NaVa greater than NbVb. So, which product is greater for acidic solution? Product of normality and volume is greater for acidic solution. What is the reverse case for basic solution? Which product is greater? Product of normality and volume in case of base is found to be greater, then definitely that solution will be basic one. And if both products for acid as well as base, which product? Normality and volume product for acid and base are equal, then that kind of solution is known to be neutral solution. So keep in mind, these are the three important conditions: acidic solution, basic solution and neutral solution. So in next session, we will discuss with further theoretical points.
Next.